Greetings and welcome, ladies and gentlemen. We're talking yet again about roots of real numbers. Part 2, right? So I want to start off today with an example. And we're going to do some sign analysis of kind of our elements and terms within our expressions, right? And another way to describe the sign of a number is its polarity, like poles, right? Like magnetic poles, positive, negative, or north and south pole, positive and negative. So that's what we're going to talk about today. So let's talk about the square root of x squared. All right? And let me ask you a couple things. What is the polarity of x? Before I square rooted it, x is x. So could x be positive?
Yes.
Could x be negative?
Yeah.
And then I guess it also technically could equal 0, but I'm just interested in positive or negative right now. But yeah, it could equal 0. So if I have this positive or negative number and I square it, what is the polarity of x squared?
Positive squared.
If it's positive and I square it, it's still positive. If it's negative and I square it, negative squared, right, is positive because a negative times a negative is positive. So x squared is positive only. And now if I square root x squared, the square root of a positive number, well, this is the principal root, so it's going to give me the positive back. So what I want to point out here is that, yes, I agree that the square root and the square cancel out and I have x. However, I don't have the negative versions of x. I only have the positive versions of x. So one way you could denote that is with absolute value. Meh, wonderful. Right? Because the square root of x squared can't equal some negative number if x was originally some negative number. Make sense-ish? Let's keep going. What if I've got the cubed root of x cubed? Okay, let's analyze this. So what is the sign of x before anything happened to it? Could it be positive? Yeah. Could it be negative? Could it be 0? Sure. What about when I cube that? If I cube a positive number? Positive. If I cube a negative number, negative times a negative is positive, times another negative is negative. So the cube could be positive or negative. So when I cube root x cubed, if x cubed was positive and I cube root it, I get one answer, and it's positive. If it's negative and I cube root it, I get a negative answer. So this one, when I simplify this, the cube root and the cube cancel out, I get x, and I actually do mean that it's equal to what originally x was. If x was originally positive, then it's positive. If x was originally negative, then it's negative. Whereas when I had the square root of the square, I was only interested in the positive possible values of x. Okay? Kind of weird. Let's do one more. Fourth root of x to the fourth. Let's consider the polarity. X could be positive or negative. X to the fourth. If x was positive, it would be positive. If x was negative, it would be positive. Because a negative times a negative is positive, a negative times a negative is a positive, and a positive times a positive is a positive. Let's see. Can I actually do my little... Let's see. Let me see if... Oh, here we go. Aha! Maybe some of you on the internet haven't seen me yet. So this is crazy. So if I've got 4 numbers being multiplied, yeah, you guys can see that. Here we go. The negative times a negative is positive. This negative times negative is positive. And a positive times a positive is positive.
Well, we can't do that in our hands.
Yeah, it's a pretty good trick. Actually, another trick that I used to do was I used to FOIL this way, where I do firsts, outer, inner, lasts. It's a pretty good one. Right? I don't know. But anyways, that's the idea right? I've got an even number of negatives being multiplied. So, all right.
Can you scroll back up so I can take a picture of the board?
Take a picture.
No, it's boring.
I'm tired. I don't want to write so much. I'm sorry.
This is also on video. You could just.
Yeah, but then I'd have to like go all the way to YouTube and find
Yeah, you're gonna watch
watch
Boo.
all these
So, anyways, the fourth root of x to the fourth. If x to the fourth is positive, the fourth root of a positive number, being the principal root, is positive. In fact, the fourth root of a negative number does not exist, at least not really. Really. So anyways, so the fourth root of x to the fourth is going to be a positive answer. The fourth root and the fourth power would cancel out. I'd just get regular old x. However, I'm interested only in the positive versions of x, hence the need for its absolute value. So, could some of you, one of you, any of you, all of you, put into words when does absolute value show up?
You're taking the root of even number.
Even number?
Yeah, like when it's squared over the fourth root, sixth root, so on and so forth.
So an even root
Even root, yes.
of an even number? Right, because this was odd and no absolute value showed up. Even, absolute value showed up. Okay. So let's see. So we'll call this Aaron's rule.
Seriously?
Yep.
Hooray!
And for Aaron's rule, he said that for when you're taking a radical, if the exponent and, let's see, do you guys remember what this little guy is called in the radical?
I will
And
take my
index,
You got it.
yep, are even, then the radical's answer needs absolute value. Done. So that's Aaron's rule, right? So let's consider that for a couple examples. So what if I've got the square root of x to the fourth? What would that simplify to? Square root in a fourth power.
the x
X to the square.
It'd be x squared.
in absolute value.
And because this is even, right, the little invisible 2 was hiding there, and this was even, Aaron's rule applies and absolute value shows up. Right? Let's see, by the way, the relationship between the 4 and the 2 here, I just want to point this out. Remember back in the day we had a to the m to the n? What did I do with those exponents?
Add.
Power to a power?
Oh.
We'd multiply. Instead of raising to the nth root, we're nth rooting here, which is the inverse operation, and the inverse operation of multiplying is dividing. So 4 divided by 2 is 2. That's actually one of the ways you could get that answer there. So kind of a neat little shortcut there. Now question, x squared. Is x squared positive or negative?
Positive.
Positive. So do I really need the absolute values here anymore?
No.
If x squared is positive, I don't, because it would be redundant. Okay? They did have to show up according to Aaron's rule, which is right, but then I can get rid of them because x squared is already positive, right? Now, what if I've got this? What if I have the 6th root of x to the 18th power? Let's see.
X to the third.
X to the third.
The absolute value.
According to Aaron's rule, absolute value shows up.
Why?
Because Aaron's rule said even, even, absolute value.
But what would be x cubed?
The cube comes from 18 divided by 6 is 3,
Oh.
according to this. So, and question, is x cubed always going to be a positive number?
Yes. No.
No. So this absolute value is necessary to force my answer to only be positive because that's what Aaron's rule told us to do.
So we do like
Yeah, I have to
addition
finish
on
like the last two
rule,
problems.
saying that the answer is an even exponent, then you don't need the absolute value to stay there on the answer.
Perhaps so. Let's see. Let me do another one. What if I've got the following? What if I've got the fourth root of x to the 32nd? What would that simplify to be?
X to the 8th and absolute value.
X to the 8th. Aaron's rule applies.
And get rid of the absolute value.
And x to the 8th is already positive, so the absolute value would be redundant and not simplified, which is what I'm trying to do. I'm trying to simplify these radicals, right? What if I've got this? What if I have the fifth root of x to the 20th?
X to the 4,
X to the 4th?
which is just x to the 4th, but it doesn't need the absolute.
Well, did absolute values show up? Did Aaron's rule apply?
Yeah. Then no.
No, they actually never showed up because this was odd.
Okay.
So this was our answer to begin with, but I do agree with you, Zach, that even if they did show up, I could have gotten rid of them because of the fourth power. Let's see, and how about, what if I've got this? What if I have the cubed root? What happened to my colors here? Oh dear. Oh dear. The cubed root, there we are, of, what if I have the cubed root of x to the 15th?
It would be x to the 5th.
X to the 5th. Did absolute value show up?
Yes. No.
No, because both of these were odd. And so absolute values didn't show up. And I'm done because they never showed up. But if they did show up, they would have had to stay because this is an odd exponent. All right? So that's the idea of Aaron's rule. Let's see, could someone besides Aaron come up with a rule regarding when absolute values disappear?
I don't even know why they disappear.
Let's see, this situation, this situation, this situation. Why did they disappear in two of them and stay in the other one?
Even when
Okay, could you put that into words, you think? No?
no,
What part was even?
the exponent.
The exponent, okay. So when the exponent's even, what happens?
The absolute value signs disappear.
Sure, and if the exponent is odd,
They say.
perfect. See, you had words for it. So we'll call this ZACHK.
Doesn't matter.
Which do you go by?
H.
All right. I had a friend who went by K.
A lot of people do.
Do they? Actually, Zach, he's a Lego Maniac. The theme song from the 1980s. I believe he might have been a K Zach. But anyways, Zacks Rule, all right, was this, that if the exponent in an absolute value is even, drop the absolute value. Right? So Zach's rule is all about getting rid of absolute value. Aaron's rule is about making absolute value show up. Okay? So apply Aaron's rule first, and then figure out if Zach's rule applies after the fact. Don't try to apply them at the same time. Otherwise, it likely will not work. So let's try this example here. What if I've got the square root of, what if I've got 81x to the 12th, y to the 20th, and z to the 17th?
No, it doesn't work.
Well, let's see. Square root of 81, what does that become?
9.
Is 9. Square root of x to the 12th
X to the 6.
is x to the 6th. Did absolute value show up according to Aaron's rule?
No.
What's the index here?
Oh, yeah.
It's a little invisible too. Even, so yes, absolute value showed up. Right? A little invisible too, hobbit wearing a ring. 2 is the hobbit in the land of radicals, right? For y to the 20th, what does that become? Y to the 10th. Did absolute value show up?
Yeah.
Yep, even. Okay. Now z to the 17th, I can't even simplify in that current form. However, what is a number smaller than 17 that 2 goes into? The largest number smaller than 17. So we'll break this up into z to the 16th times the square root of z to the 1st. Do you guys see where that came from? Right, 16 and 1. Multiplying two things of the same base, you could add the exponents and get 17. And by doing that, by pulling out as many of those z's as I can, I'm going to be able to simplify that radical and get most of them outside of the square root. So let's keep simplifying here. So 9 is cool. Does Zacks rule apply to this x?
Yes.
Yes.
But 9 is also absolute value according
Well, but 9 was already defined as being positive, so I don't actually have to have it show up. And technically, yeah, you're right. It would have shown up if it was a variable, because 81 was the same as 9 squared. That would have been even. But because it's a number, I don't actually care. It's only when there's variables. So let's see. Zacks rule applies because the exponent is even, so that's x to the 6th. Does Zacks rule apply on y to the 10th?
Yes.
Yes, so those absolute values drop. Square root of z to the 16th is what?
6,
Z to the 8th. Did Aaron's rule apply?
yeah.
Yep, so absolute values show up. In fact, while we're here, does Zacks rule apply?
Yeah.
Yes, so actually all of those happen to lose their absolute value, so that's a good deal. And then I'm left with the square root of z stuck on the inside, and this would be my answer. It is possible, however, that you might have one of these like still stuck inside absolute value just hanging out, and that's fine. But so this lesson is primarily focused on the polarity, right, or the sign of these particular variables, right? So be careful with that. So I think that's actually all we'll need for today, and then we'll end up doing some partay work. But thanks for watching, internet friends. Bye-bye.